So this is the second part of our topic 1, and it's on describing matter. So this goes into the particle theory. It says all matter is made up of very small particles. All particles in pure substances are the same. There are spaces between particles. The amount of space varies depending on the state of matter. And particles are always moving. As particles gain energy, they move faster. And the particles in a substance are attracted to one another. So that's a lot of stuff. Let me break that down a bit. So if we look at matter in general, matter is really just anything that, I guess, has a mass. That's what we consider matter. And the first thing here, it says that all matter is made up of a very small particles. So we can't see with our eye what these particles might look like, but we're going to have to just understand that there is particles, very small ones, and they make up all matter. All these particles in a pure substance are the same. So when we think of a pure substance, that means that it only has one type of particle. And for us, when we're doing chemistry, all of our pure substances are found on the periodic table. It says there are spaces between particles. The amount of space varies depending on the state of matter. So lots of particles basically depend on, or the particles in a type of matter depend on their state. And if we think about what types of state of matter, you guys maybe have learned about this before, but we've got solid. Can I write? Okay. We've got solid, liquid, and gas. So depending on the type of matter, that's going to depend on how much space is in between the particles. And basically the more space is as we go down this list. So solid has the least amount of space in between. They're very closely packed together. Liquids, there tends to be a little bit more space, and gases, there's even more space. All right, so that's really depends on the state of matter. Particles are always moving. So even in a solid, the particles are moving. They just sort of vibrate back and forth. And as you get from liquid, they move a little bit more or a little bit faster. And then in a gas, they're moving around a lot more. And this has to do with the state of matter, but it also has to do with temperature. So temperature can be a factor in how fast these particles are moving. The particles in a substance are attracted to one another. So all the particles in substances are attracted to one another, and that's what sort of keeps them in that state of matter. Oops. Okay. So it shows us our states of matter here. Matter may exist in 3 states depending on how close or far apart its particles are. So we've got solid, liquid, and gas, and that shows you sort of in those pictures what I was talking about. But solid, closely packed together. Liquid has more space. And in liquids, we can have things that will go in between the particles. So if those were water particles, we can put mixed salt in or sugar. And then gas, they have even more space, and they normally take up the shape of the container that they're in. It says solids here are tightly packed together, and they move very little as a result. This causes solids to retain their shape. When particles gain energy, they heat up, they expand or move apart, causing solids to turn to liquid. So ice melts to form water. So when we heat stuff up, it expands, and you might see that, when we're heating up water, for instance, that's them moving apart. So those particles are tightly packed together as a solid, and as they move apart, they would become a liquid. And then when they move even farther apart as a liquid, they could become a gas. In liquids, particles are slightly further apart and thus able to move around. This causes liquids to flow and to take the shape of their container. When particles gain energy, so when they heat up, they expand even more, and this causes liquids to turn to gases. So water is vaporized as it begins to boil. So that might be what you see when you're boiling water and you have steam. So that water that was once liquid is turning into a gas or a water vapor. It says when particles lose energy, when they cool down, they condense. They come together. So condense, if I can, nope. There we go. So this word condense, this is come together. I'm gonna say they pack in closer. And this causes liquids to turn to solid. So when water freezes to form ice. So we can have liquids that will go backwards towards condensing, and that is what we see when a liquid turns to a solid. Gases, those are loosely packed, they freely moving particles. Gases disperse throughout the space they are in. And when particles lose energy, they cool down, they condense or come together, causing gases to form liquids. Water vapor condenses to form water. So when water particles, they lose their energy, they're going to start to become a liquid that's also condensing or going tightly packed back together. So when we think of solids, liquids, gases, if we put it on a sort of a continuum here, if we're at a gas state, don't know why it's not going. If we're in a gas, in order to go backwards from there to there, it's going to have to condense, okay? So going backwards is condensing. A liquid to a solid is condense. And then if we're going the other way, so we're going left to right, that is expanding, I guess. I'm just going to say expand. So the particles will expand or move farther apart. All right. So in order to go from a gas to a liquid, you're going to condense. In order to go from a liquid to a gas, it's going to expand. So remembering this little, I guess, flow of how things go from solid, liquid, gas, and back and forth. I don't think they talk about it in here. No, they don't. There is, oh, maybe they do. Yeah, they do. The picture on the next slide tells you basically the same thing I just drew, but you can actually go from a gas to a solid or a solid to a gas. You can skip that middle step, and that's called sublimation, which I'll show you in this picture. I just don't know why. Okay. So it says through the addition or loss of energy, matter can change states. So if you look at this, if we're going from solid to a liquid, then it's melting. If we're going from a liquid to a gas, it's vaporization. And if we're going from a gas to a solid, then that's condensation. This particle theory also helps explain other properties of matter, physical versus chemical properties. And I will put that video in the Google Classroom so that you can watch it because you can't watch it in this video.